Hello and welcome to our presentation in which we'll be taking a look at optimal NLP algorithm combinations applied to Moroccan dialect, analyzing comments about elections. So this presentation was worked on and created by Othmane Tayab, Amine El Iraoui, Hasan Sfouli, and was also supervised by Professor Aaroud. Before we get into the presentation, I'd like to just take a look at the table of contents. So for the first two sections, which I will be taking a look at and explaining, are the introduction and challenges and known solutions in our approach. For the third section, machine learning applied to Arabic Facebook comments, my colleague Amine will be explaining. And finally, the results and conclusion will be given to you by Hasan Sfouli. First of all, in the introduction and challenges, we have definition of sentiment analysis. So sentiment analysis is a process in which the polarity, either positive, negative, or neutral of a given text is determined. And the objectives behind doing any sort of sentiment analysis are to analyze opinions, feelings, attitudes, and emotions just from the text that someone wrote to express themselves. Also, it helps us make sense of what the general population thinks of a certain topic. Like, for example, in this presentation, we'll be taking a look at the general feelings from comments on Facebook shared in standard Arabic or the Moroccan dialect about the Moroccan elections. Although it might seem like it's a straightforward subject, but there are some challenges that come with trying to do sentiment analysis on Arabic comments. Like, for example, we don't have enough data to create a really good model by just using the basic solutions that are optimized for English. Which is why we had to go with a unique approach. But first, just a brief overview of the various types of solutions out there. The first is lexicon-based and the other is machine learning-based. The latter, my colleague Amine will be going more in depth on, but first of all, for the lexicon-based solution, there are usually predefined collections of words which are annotated to reflect each one's polarity, which could work really great with well-structured languages such as English or French. But this won't work well for us as we have a very unstructured set of comments in the Moroccan dialect, which is why our approach consists of using machine learning and deep learning techniques, as well as supervised text classification and testing the best combination of NLP techniques on algorithms for the Arabic language. Moving on, my colleague Amine will be explaining the following section of how machine learning was applied to Arabic Facebook comments.
Part, I'm going to show you how machine learning applied to Arabic Facebook comment. The sentiment analysis of Facebook comments written in standard Arabic or Darija using a machine learning approach requires the implementation of several steps. The following figure provide an overview of this process. In the following paragraphs, we will be describing the main responsibilities of each step. First of all, data collection. Second, data preprocessing. Third, variables extraction. Fourth, variables selection, classification, and evaluation. In this part, I'm going to talk with you. I'm going to show you how can I does collection and preprocessing of Facebook comments. For the collection, we are able to come across an open source dataset hosted on GitHub, so there isn't much to be explained there. As for processing the collection of comments, the objective is to extract variables in the form of words or sequence of words to use them in the classification. The quality of processing, therefore, clearly has a major impact on the performance of classification models and the result obtained at the end of the process. We start this step by cleaning up and normalizing, our text, removing signs like this, and symbols, repeated letters, stop words, or words that do not provide any information regarding the subject studied. The next task is the tokenization. In this step, in this process, we in this process in which the text of the comment is divided into lexicon unit tokens in a text in modern Arabic or Darija. These units are more complex to develop more complex since they often consist of more than one word. Hence, the importance of the steaming process to develop and apply a steamer on the comments collected were inspired by the light 10 steamer of Likely and All 2007, which proposed the elimination of the most common prefixes and suffixes of a token in the modern Arabic language, in which we add an extension for Moroccan dialect Arabic. The following table show you an example of preprocessing a comment. So we're moving to extraction and the selection of variables. Supervised learning sentiment analysis requires the priority determination of the polarity of the opinions expressed in the text to construct the objective variable to annotation of the comments collected was done using crowdsourcing. This task was given to a group of volunteers to define the polarity of the comment, positive or negative. In the end, 6,581 comments were marked negative and 3,673 positive. The input variables are automatically extracted from the corpus form to pre-processed comment using in-gram extraction and TF-ADF whitening schemes. Studies such as the of Pang and all 2008 have shown that the quality of classification models depends on the specific of the data used. To test this, we test six combination of extraction and weighted schemes to ensure the best quality of models developed. The third, the comment classification. To classify Facebook comment, we applied three supervised classification algorithms with the Python language programming, naive Bayes, and random forest and supervector machine. And more, and for more result, for Mr. Hassan, you can show you the result. Thank you.
Machine learning applied to Arabic Facebook command. Extraction and selection of variables. Variable. The command classification. To classify Facebook commands, we applied three supervised classification algorithms implemented using the Python programming language. Naive Bayes and random forest and support vector machine or SVM. The combination of extraction and within schemes allowed us to test six different configuration or six datasets for which we applied the variable selection score. Each dataset was split into three subsets: 50% for training and 25% for validation and the rest for testing. The table 2 summarizes the result of the experiment carried out. Here we have the table for accuracy of the tested configuration with selection of 1,000 variables. Analyzing all the scores or the accuracy with all variables, we found that the Enneagram TF-IDF and the Enneagram P-gram TF-IDF combination is the most efficient combination in those six combinations. and the same time for selection of 500 variables, we see that Enneagram TF IDF and the Enneagram Bgram TF IDF is the best performance combination. Result. In general, this result show that the best performance was obtained with the combination Enneagram TF-IDF and Enneagram Bgram TF, regardless of the algorithm used, considering the impact of selection of variables for the different configuration. We can conclude that the second configuration with the Enneagram extraction and TF-IDF weighting is the most efficient in terms of the ratio good reckoning rate number of variables. Conclusion. This project focuses on sentiment analysis using Facebook command written and shared in standard Arabic or Moroccan Darija. The proposed process was applied to data relating to the Moroccan legislative election of 2016. Several combinations of extraction in gram and within TF and TF-IDF schemes. For the construction of the variables, we tested to ensure the best performance of the classification models developed. The result showed that the quality of the models depends on the subset of variables formed from the combination of the extraction and weaving schemes. Applying a variable selection method allowed us to reduce dimensions while maintaining a similar or better level for performance. And finally, thank you for watching.